Howdy, everybody. Hope you're doing well whenever you are. We're here for Quest 8 of Everybody Codes. Today's been a long day, so I'm recording this a little later than usual. Hopefully, not a bad day, because I think I'm mostly out of mental capacity, but we'll see, I guess. Just check really quick to make sure. In a little bit. Nice, everyone. Okay. Great conversations. I appreciate everyone. I've had a lot of good conversations on Reddit too, so I don't know if those people watch my videos or not, but it's always fun to learn from each other. And so I've been looking at Rust solutions, but even like yesterday, I found a solution in Kotlin that helped me figure out the caching part that I was missing that really improved my performance. So anyway, really cool stuff. Let's just get on with the day. The rest of the journey to Stack Trace Sanctuary passes with a pleasant atmosphere of jovial exchanges with Veronica. Despite being young, the Nerd Master possesses impressive knowledge about magical creatures, particularly dragon ducks. With each passing moment, her fascination with your presence seems to grow stronger. Dragon ducks are one of the rarest and most extraordinary creatures ever known, Veronica says passionately. Each of you possess a unique skill that defines who you are. But the most intriguing thing is that these skills develop you not only internally, but also physically. Veronica points at you. Let's take you as an example. Your skill is definitely solving puzzles. Look at yourself. You're already the size of an adult human. And from what I've read, young dragon ducks are usually only slightly larger than normal ducks. You must be either exceptional or very hardworking. You ponder her words. Your entire journey so far has been filled with riddles and puzzle-like challenges. Every solved task made you feel more confident, stronger, and taller. During the next stop, Veronica shows you another book filled with numerous diagrams and notes. In this book, I have gathered puzzles that were devised by dragon ducks with skills similar to yours. These puzzles seem to be designed specifically for you to grow stronger. If you want, I can show you my favorite, which has become a type of artwork practiced by many artists these days. Yo, that's cool. So you use a single thread, and just depending on like where you draw the threads, you make it darker or not darker. The artwork referenced in the book is called string art. To create such a work, you need a wooden board, tiny nails, and a very long piece of thread. First, you need to draw a circle on the board. Next, hammer nails around the circle at equal distances. The more nails you use, the more details you will ultimately achieve. Once you finish hammering, number the nails in a clockwise direction starting from 1. So 1 through 8. Assuming we have only 8 nails, it looks as follows. 1, 2, 3, 4, 5, 6, 7, 8. The process of creating a string art involves threading a string between nails according to a specific sequence of numbers. You should execute the entire sequence with a single thread, connecting nails with straight lines without breaking the thread at any point. The first part of the challenge allows you to verify your understanding of all the rules. Assuming you have 32 nails, construct string art according to your notes and count how many times the thread passes through the exact center of the circle. Okay. For the sake of the example, let's assume you only have 8 nails, not 32. According to this sequence, you start your nail number 1, and number 2, so on. Okay, so the only time you'd go through the exact center is if you were directly across from someone. So like if we assume it's 8, we know the directly across is 4. So we know the absolute value should be 4 of the difference of the two numbers, right? For the given example, the thread passes exactly through the center of the circle 4 times in the first, third, fifth, and eighth step. How many times does it pass? Okay, so we have a much larger list, and we're doing it 32. Our parser is numbers. That shouldn't be too tough. But this one, I think, at least the part 1 shouldn't be too tough. So we actually are going to return a vec of usize. And we'll do trim split on commas map first wrap wrap. I can spell correctly. Let's collect it. So for this, we'll do input dot windows of size 2 dot filter we'll have a constant size as u30 is 32, and middle is divided by 2. So then here we just have our window, and we say I should make these eye sizes, huh? We just do that minus that abs middle because I'm counting. That's function. Well, maybe we should pass the size here. This because then we can do the test case as well. So we can do so here we do 32, but we can create a test case. I added like test case things just so we could do. So let's do. I'm really bad at remembering alt tab. We do search. But what's the 8? 8. Tell you what, I am. The answer should be 4. Okay. That looks like it's right. So 57. Ooh, ooh. I'm getting really bad at that. I need to remember my fun. But there we did it. Okay, that one wasn't too bad. Part 1 at least. Because again, like, so what is the thing you have to get here, right? Is like, if you have a circle, how do you tell if you're on the other side of a circle? It's like you have to be halfway there. So you just need to know that it's the total number of dots divided by 2. Otherwise, you'd never cross the center. Like, even if there were a million of them and you were just off by 1, like, it wouldn't technically cross the center point. Although we'll see, that may change. So like, how does that like translate in code, right? Again, all we're basically doing is saying, let's do windows of 2 and check to make sure that the distance between them is exactly the size divided by 2. So again, here, imagine you're taking windows of 2, 1, 5, then 5, 2, then 2, 6, then 6, 8, and so on and so forth. And you're literally just checking every single value and saying which ones are there, which ones. So that just feels so bad. Oh. All right, let me try and fix it. Okay. Do part 2. Okay. Part 2. Very large string art projects require additional stabilization. If we cross the threads, we tie a knot. Even if several threads cross at the same exact point, we need to tie a separate knot, with each of them individually. The next page represents a sequence of 256 nails. Construct the string art and count how many knots need to be tied. Complete the whole thing. To complete the whole thing. Example. So if we do the simple example, like, this has to get tied because it intersects. Right? So we go here, or sorry, down here, then up here, then from here to here we cross, so we intersect, so there needs to be a knot there. Then we go up, then we go across, and there's 2 knots here. Oh, because it's hitting this 1 and 2. And then right here, because it's hitting this one. And we go back up, it intersects here. We go back here, it intersects here. We go back here, it's like 1, 2, 3. So it's these 3 lines, and then these 2 lines it intersects with. And then these 2 it intersects with, and then these 2. No intersections here, but then from here to here, it's 1, 2, 3. Okay, so I think what this is just going to ask is like, does this intersect some other value we've had before? And I guess I want to ask myself, like, how do we want to determine whether it intersects? So, we could say, like, if we follow like a a pattern, like if we know we're going from, how do I say this? If we know we're connecting 4 and 8, if we take the largest number and then go through all the previous visited ones and asks ourselves, how many of those do I have to step over to get to that one? Or maybe if it might actually be easier to go backwards. So we start at 8 and work our way down and say, how do I, like the way to think about this is 8 is going to cross over all the lines that have a number 7, 6, 5, and 7, 6, 5. And so and 5 has 2 of them and 6 has 1 of them, so we know the answer is 3. Is that right? So at first there's none. And then the second time around, there's still none. Then the third time around, we're going from 2 to 6. So we start at 6 and we count back to 2. And we say, do I... Ooh, this is an interesting one because what it's saying is I won't overlap. So maybe that's not quite right. I feel like I was close to something there. So when I'm laying this 2 to 6, maybe the way to think about it is I'm going to go from 2 to 6. I'm going to go from 2 to 6. And that might include wrapping. So like say I'm going 8, 4, I go 8, 1, 2, 3, 4. So I'm going to go, forward modulo. And I go 3, 4, 5. I know I won't do this one because I'm attached to myself. And then I do 6. And so I draw it. Okay, so let's try a more complex example. This one is 8 to 4, so I'm right here. So I go 1. That one is 2. That one has 2. 3, 4, I'm done. Now I do 4, 1, so I go 5. Yes. Oh, I actually want to go the shortest distance around, I think is what it is. So I figure out what the shorter path is. Is it to go this way or this way? And then I delta. Because this one I want to go this way. So I go 1, 2, 3. And the 2 has these 2. So I know I'm it. 8 and 4 directly across, so it doesn't matter. I should be able to do it either way. If I go 1, 2, I know it's not this one because it's at my origin, but this 6 to 2 does. And then I go here, and now I have a 5 to 1 and a 5 to 2. Then I go to my 4. Okay, I think we definitely want to do the test case here. And we definitely have a bigger selection of things. Okay, so we're going to do it with 8, but then the actual one is 256. So P2 will ask for a size, I size. Still get the input. And then do 256 here. For our test case, probably should have done this before. For the copy paste, it'll be 8. But we're doing part 2. And we expect the answer to be 21. Okay, so that's definitely going to fail for part 2 for now. Okay, so let mute strings equal vec new. So we'll have an empty set of strings, and then we'll still do windows. So we'll do for w in input.windows. Let count equals 0. We're going to return count when we're done. We're going to do windows of 2. And so what is the logic in here? We need to first determine how, which direction we are going. Oh, did you guys hear that? Next, trace to that to the end position. We should do like let start and equal w0 w1. Trace to the next end position and look for strings connected to the current point, connected to the points between, but not the start or points. So the delta is going to be how do we determine which way we want to go? So if I'm going from 8 to 3, I do 8 plus 3 modulo len? Let's see. If I'm going back, it's easy. It's start minus end. How do I get this length? It's len minus end plus end plus start modulo len. Did I say that right? Oh, interestingly, it's 1 based. Ugh, so I almost want to subtract 1 from them. I know that sounds silly, but maybe it's not. Oh, it won't let me do the windows. Okay, so we do each position is going to have to be -1 though too. I might do it right here. Okay, so we say the delta is going to be if start minus end. Oh, but what if I go, what if I'm at 2 and I'm going to 8? Two minus 8. Okay, the absolute value, I want to do the absolute value of the subtraction for that, for one way, right? For clockwise. There's probably a better way to do this, but I think I have to do, it's going to look funny, but match start greater than end. And if start is greater than end, we'll say if start minus end less than start minus end less than so start minus end size minus end plus that gets us this section, and then we just need to get this section, right? Oh, plus start. So just plus start. So if start minus end is less than that, that would mean we want to go counterclockwise. So -1, else 1. Now, if this is false, what do we want to do? The opposite? No, not really. We want to do if end minus start. So if like we're going from 2 to 5, for example, so we go end minus start. That would be clockwise. We'd want to go clockwise. But if it was 7, we'd want to go size minus that plus that. So it'd be close, size minus. In this case, end is greater than start. So minus end plus start. If start is greater than end. I feel kind of confused because they're the same things right here. Except this is switched. If start greater than... Oh. So let's check this one again. Don't do this when you're on no brain power. So we're going 8 to 2 this time. No. Yeah, I do have them mixed up. If start... No, that is right. 8 to 2. So I'm going from 8 to 2, let's say. I want to ask myself, start minus end. So do I want to go counterclockwise? Is less than size minus end plus start. I go counterclockwise that way. Okay, so maybe I do have it right. If end minus start. So now I want to go 2 to 8. So 8 minus 2 is less than 1, 2. I want to go clockwise, otherwise okay, I think that is right. This could probably be compacted. Someone will have to tell me what's a better way to do that. But we got that. Now we're just going to go for those directions. So we'll say can I do that? Yeah. And we say while start does not equal end. We go start plus equals delta. And now we have to ask ourselves, we'll say, we want to know if any of our strings have this number. So we'll do strings.iter.find so we'll say L equals start or R equals start. And I may have to do them one at a time. So L is equal to start and R does not equal W0 and R does not equal W1. Or we want to do the same thing, but var dot start and L count. Oh, we want to do filter, and then we do count equal this. And then after we're done with this, we do strings dot push w0 w1. That work? No. Oh, it's never going to finish it because it goes forward. I actually need to start equals start plus delta rem. Oh, actually, I think I can go modulo. Still not? Oh, it's actually doing the part too. So I sort of want to comment this out. Maybe I should just do C test. Part 2 does not finish still. So why isn't part 2 finishing? You got some bug somewhere? Oh, this end does not change. That's right. So if we're subtracting, even if these were wrong, like the question is like this. Maybe we should. The test may not show the prints because it like stores it, so we may have to do this. Put it right here. Oh, my EC stores the data, so I just need to cargo run 8 negative numbers. Oh, if I'm going backwards. So I do need to do the rem Euclid size. That's almost certainly the issue. I mean, it's failing, but at least it's now not blowing up. Okay. Left is 36, right is 21. So what cases am I not missing? Or am I missing here? I'm doing too many. Oh, does it actually matter which way I go? Maybe I'm overthinking this. Do I just count around and ask myself, am I inside one of these? I think I am overthinking it. So like so for this case, I'm going from 2 to 6. For each of the strings, I just want to say, is there a number that goes this way and a number that goes this way? That's between these two and between these two. There needs to be a number on this side and a number on this side. That seems simpler. Let me straight that new start end this. I don't want to get rid of this stuff quite yet, just in case I'm way off. But let's do strings.iter.filter. Have something in here .count. We just do return it instead. So what is this inside? I think we want to say, is there a number between start to end? Is there a number between end to start? And these are exclusive. Hmm. Oh, I should do dot skip one dot skip one. So I don't do the start and end. And so then I do s2e dot contains l or s2e dot contains. Or let's see, it's only the cases where and e to s dot contains r, or the opposite, right? Ooh, still wrong. Oh, I'm not adding. Still 0. Hmm. I probably don't want to be doing this. Oh, 2. Oh, this if they're going the wrong, it never goes the other way. So how do I do a count? Oh, I just do this probably, huh? I do. Oh no, did I? End to start. this is not working the way I want it to work. I was thinking what I could do is, I can just rev the things, but that doesn't actually work either. So I do need to. So I do need to kind of find out. Well, we know start is the lowest and end is the highest. So start to end, this one's going to go good. And this one we need to go. We need to go like end ... skip one, but we take end minus start. So we're going to keep going, counting up. Okay, what is our test case? So 1 to 5 is actually 0 to 4. So I would expect it to have 1, 2, 3 here. And then 1 to 5, 3, 4, 5. It's including this value. Start to end. Wait, why are these 5, 2? So our start is definitely skip one because we don't. Let's put here to see it. I'm clearly missing something. Okay, yeah, so our first one is 1 to 5. So 2, 3, 4 is right. 6, 7, 0. That actually looks right. What is this 5 to 7? What am I doing wrong here? Test P2 fails. Okay, cargo test. Am I just missing input for my thing? 0, 4, 5, 7, 3. Okay, so the first two should be 0, 4, right? I've got some bug here. I mean, this should make a difference, but why am I not 1, 5, 1, 4, 1, 5, 1, 5? Am I doing something absurd? What? Zero, 4. Oh, right. I don't expect there to be any in 0, 4 because it's an empty string. Okay. But then the next one is 4, 1. So we're going to go from 1 to 4. And it goes 2, 3. Then 1 to 5, 2, 3, 4. 6, 7, 0, 1, 2. So 2, 3, 4. Actually, I can move these out here, right? Right here. One, 2, 3, 5, 6, 7 is correct. 1, 4, 2, 3, 6, 7, 5, 6, 7, 0. Correct. 1, 5, 2, 3, 4. And then we go 6, 7, 0, 1, 2. But this should just go 6, 7, 0, 2, 3, 4, 6, 7, 0. So it's this this one right here is off for some reason. We start at the end and we count forever. The question is, how many are we going to take? We definitely, so we start at, let's look at it. Like we're going from, say, here to here. Oh, this is the one. It's just size minus this plus this. This was the one, so we do. Oh, hey, we did it. Holy cow. Okay, we can probably clean this up a little bit, but let's just, I mean, it works in the test case. So let's uncomment this and see if it works. Oops. What? It's my little, one day I'll get used to my new setup. People, sorry. It is not fast. This. 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 Whew. Holy cow. Okay, so I had a lot of figuring out to do on that one. My implementation, I think, was overly complicated the first time, and so the simplification helped, but it took me a while to figure out how to get the numbers from start to end and end to start. I mean, that was a 50-minute solve. Can I blame it all on it being a long day and me being tired? Probably not. But we can be nice to ourselves. So what does the solution do, though, right? Is it figures out I'm gonna find all the numbers in between start and end and start, and then I just need to, for all the existing strings, find out if those strings are contained in the list, or if those strings would overlap. Is maybe just ask the question. We'll fix it up in a little bit, but like, what do I mean by that? What is the algorithm? Is like when we're placing 4 to 1, we ask ourselves, like, are there any strings that have a line on 5, 6, or 7 and a line on 2 or 3? And it turns out that 2 to 6 and 2 to 5 are on there, so we include those two in our counts. Okay. But yeah, it's pretty slow. It's taking 200 milliseconds. I suspect the slowness is this part right here. We're like creating these chunks. So a speed optimization might be to figure out a way to do that calculation. Like, say, is there a number between start and end? And end and start. Should we think about that for a second? We already know what start to end is. So it would be like next input. We can verify our changes. We know our start and end points, so we can say in here, we can say L greater than start and L less than end. So here's why that doesn't work and why we have to do some thinking. Suppose it's we're on this case right here or whatever. Like we're at 1, 4. So like we want to ask ourselves, is this 4, are any of these numbers, maybe that's not a good example. I want to try and find one. Yeah, like this one, right? So I need to know, is this number between, like this string 1, 7, does it overlap 8, 2? And like the question I need to ask is, it's pretty easy to ask, is one of the numbers on this side? But it's a little bit harder to ask, is one of the numbers on this side, right? And what we're saying is 1 between 8 and 2? And the answer is if what? Two. If 1 this 2 is less than 1 is perfect, but this it's like the number is between len and end and start and 0. That may be the way to do it. So this is the base. So L is between this and L between that. And R is greater than end or less than start. Is that right? It needs to be greater than end or less than start. I don't want to spend too much time trying to figure this out, but hey, that does it. Okay. Okay, that feels a lot better. Solves quite a bit faster. We can look for more optimizations later. So let's just move on to part 3. Part 3. The art of string art has also been adapted to create symbols with magical properties. With their help, for example, a special pattern can be marked on a knight's shield, which then, stimulated in the right way, generates a shock wave. Knight can activate the spell at any moment by cutting through the symbol with a sword. You must do it in such a way that the cut passes through 2 nails on the circle. The more threads cut, the greater the effect of the spell. The next string art has 256 nails. Find the best strike to activate the symbol and count the number of threads that the sword cuts through at this activation. Okay, so we make our little thing. And then the question is, which cut intersects the most? 8 and 5 would cut 4. 1, 2, 3, 4. This would cut 2. 7 and 3 would cut 7. Okay. Let's do 3. And then 6. It's gonna copy paste. So how many times did I copy paste it? Did the wrong one? Please let me blame it on the tiredness. People are excited to get home today. Okay, it's not the right answer. Oh, that's funny. We don't use size. Here. I guess that's right, because we don't need to do the modulus because we just do the wrapping. Okay, so we actually just want to collect the strings, so we'll just do input dot tuple or tuple. Does that do what I think it means? Return an iterator that groups the items in tuples of a specific size. 1 to 5. 1, 2. Tuple windows is probably what. 1 to 2, 2 to 3, 3 to that one. We want tuple windows dot select back that. And now we just want to try it's like for x in 0 dot size or y in x dot size. Paste this and do what are the odds that oh, I guess this should be start end. This should start this one. Will that do it? Or do I need to dereference these? Okay, can I do this instead? What doesn't it like? I don't think it's an off by one error. It's failing by one. Oh, you can't see this bottom part. It's failing by one. It's saying left is not equal right. Left is 6, right is 7. Maybe I can shrink this down a little bit. I don't think it's an off by one error. So something's got to be wrong. Because like my thinking is, oh, literally just try all the options and see how many intersect. Two 6, so 3 7 is 6. 3, 7 would be 4, 8. How many does it cut? 1, 2, 3, 5, 6, 7 as well. Why is it 0, 2, by the way? Oh, it's never going to do the one directly next to it. I need to be at least 1 away. So that's why it skips it. I mean, I can try, if it's off by 1, I'll be very mad. Yeah. Because I don't think it's off by 1. So why is it only counting? Let's look at the test case and go from 1 to 3. It cuts twice. 1 to 4. 1, 2, 3, 4. That's correct. One to 5. Actually, it doesn't cut this one. It cuts 1, 2, 3, 4. Yeah, that's right. 1 to 6. It cuts 1, 2, 3. Okay, wait, this one's off right here, right? This is equivalent to 1 to 6 from here to here. So it definitely doesn't cut here, but it does cut here. And it does cut here. So let's get the details of that one. Let's so let's say if start equals 0, 5. L. Oh, it's going to be above it because the way I have it set up. I mean, it's really ugly, but so now we can look at all of them. So we're going from 1 to 6. And now we want to test 1 to 5. No. 2 to 5. No. 2 to 6. No. 6 to 8. No. 4 to 8. Yes. One to 4, no. 1 to 7, no. 3 to 7, 3 to 7, yes. 3 to 6, no. 2, 1. We're only getting 2. So which one am I missing? The trues are 4 to 8. Okay, so, maybe do it this way. If I cut from 0 to 6, what ones am I looking for? 2 to 6 should be true. Yes. Oh, actually, should there only be 2 here? Because this one crosses and this one crosses. It actually should only be 2. Okay. Which one I know is wrong? Okay, we know the correct answer is 3 to 7. So let's try that one. 2 to 6 then. One, 2, 6. So what cut am I missing here? So the first cut is 0 to 3. Is that on my list? Yes. Next one is 1 to 4. Yes. The next one is 1 to 5. Yes. Next one is 0 to 4. Yes. Next one is 3 to 7. Yes. The next one is 6 to 8. So, sorry. 5 to 7. Yes. The last one is... What's this one? 3 to 7? Why does this one cut? What's this dot that it cuts? Oh, it cuts 3 to 6. No. 2 to 5 is false. Seven. 1, 2, 3. Oh, it's if it's equal? Is that what we're saying? Or equals start end. Start. That's one too many D references. I found 7. Oh, I didn't add it down here. I still get 2,800 though. Oh, it should be like this. Maybe. Just, oh, I did it the other way. It's like this. This. Oh, now it's too many. Like, how do I determine which ones I actually cut? This actually gets me. Oh. This one got me the test case, right? But it still gives me 2,800, which is not the right answer. So what this, like, what the part that I'm missing here is that there's a 3-7 here. So cutting this presumably cuts the 3-7 as well. Like, it definitely cuts 1, 2, 3, 4, 5, 6, but it also cuts the 3-7. So the question is like, well, why doesn't this number change then? Like, the question is, why doesn't it cut this one right here? Striking the symbol between 5 4 threads. Striking. So 5, 8. It's 4, 7 in my count. Four, 7 does 4. 1, 6. So 0, 5 does 2. 2, 6 is 7. Note that the thread between nails 3 and 7 is also. I feel like, doesn't that solve it? L equals start and R equals end, or L equals end. Oh, I didn't try 2800. I tried 2801. Oh my goodness. People, people. My fellow solvers. Yikers. Okay, we got there though. Um wow, that was a tough one. Really? I only spent 25 minutes on part 3. I spent more time. Look, I spent more time on part 2 than on part 3. Okay. I mean, sure. Uh, let's see. So how did today go? Part 1 was pretty easy. I did it in, it looks like 11 minutes. That includes reading time. And I really just had to think it through and say, okay, well, what do I do? Is I just parse the windows. Part 2 was tougher because I had an algorithm mistake, right? Is like I was way overcomplicating it. And I realized, oh, I just need to make sure that they intersect. And in fact, there's probably the problem with a normal intersection, like you do it if like you want to do an intersection in a graph. There's like a simple algorithm to do it, but your points are on a circle. Or you could turn the points on the circle into a position on a graph. You'd have to use floats and then it would suddenly become fuzzy. So I wonder if that affects it. So I'd be interested to see if someone did that. We'll have to look and see. But then my intuition was, oh, I should just see if the strings overlap, right? If it overlaps with any. And so what do I do in the end? I think we optimized this at the end of part 2, right? Is I just say, check to make sure the left side is between start and end, and the right side is greater than end or less than start, meaning it's the other on the other side, or do the reverse, do that for the rights. Might even be an easier way to do this. So I'd love to see how you did this. Maybe you did an easier way. But once you get there, okay, so we should comment this. The strings overlap if one side is between start and end. Third side start. So like that. And so then we can just count them. So we can actually do this in a we could do this in a fold if we wanted to make it more rusty. It would actually be a scan. So should we try that? So we say input Windows to scan and spec new have our string And because we need to do the logic. Okay, there you go. Does that look better? Does it actually matter where start and end are now? I think it does, because and the reason I say that is because, like, this math, if you didn't, if it was the other way around, and this is where I was confusing the previous one, if it's the other way around, like, you then do the other way, I think. I'm curious if it works. Let's try it, because part of me says it should still work, but let's see. Can't do that. Yeah, see, it doesn't. Yeah, I think there is some weird you have to do different logic when you're going around, so there might be a better way to do this overall, this calculation overall, but make start always be the smaller number, count all the strings that overlap, push string to this. Okay, there's a more Rust functional way. You don't have to use functional programming in Rust, right? So, like, don't feel like you have to. The for loop, one might argue, may be cleaner, but and if you're looking at performance, like, at work, we've, like, tested the performance of some of these. Sometimes scan is faster and sometimes it's not, and I can't tell what it is. It's possible that it's like the things that the state that you're maintaining and how it can optimize the iterator. But anyway, okay, so there's a more functional approach to that. So for this solution, we collect all the strings, try all possible strings, try all possible cuts, I guess. There might be, like, a case where you might be able to optimize this a little bit by saying, like, well, I don't know. Which one was the optimal? Like, what's going through my mind is there may be a way that you say you'll always get the maximum output by cutting directly across. So that would be like a side divided by 2. And this would be size divided by 2. Yeah, so you can do that and it will be faster, right? And why do I say that? Does that how much does that speed it up? Does it speed it up at all? It does. It halves the time. Oh, this one. So it's this equal X. Yeah, it like halves the time. And so like why does that work? Think about it. If you're like 1 over, or like let's say you're it probably makes more sense if I show you. Like imagine I'm cutting 5 to 8, right? This will always cut this many, but this one will always cut more, right? Because it has the potential to also cut all of the ones that are encompassed in 5, that are contained in 5. So there's no reason to check anything smaller on this side or smaller on this side. The maximum cut would always be directly across, I guess, is my assertion. Like, and you try and think of a case where that would work. Imagine if 2 is like a big one and it like connects to every single one. And so you say, oh, well, what if I just cut from 1 to 3? Well, yes, that will do it. But 1 to 5 will cut all of those that 1 to 3 cut, plus any that come from 1 to 4, right? Or that it come out of 4 is maybe the other way to say it. And so if there's none, that's okay. You still get the same number though. You still get the same maximum, and so you can always test that. So I think that's another optimization you can do there that halves it a little bit. Okay, should we go look at some solutions then, or let's check my progress first? I want to zoom out though. I can look at my pretty duck hatch. Oh yeah, getting bigger, baby. What do the leaderboards look like? Yeah, I'm not even anywhere close, right? It was like an hour and a half. Although maybe I do it just with humans. Yeah, I don't think I make the leaderboard on this one. Although I did finish an hour late. But these, I still don't think I make it, right? So, what are my times? Yeah, like this is about right. It took me an hour and a half, but because I'm like this far behind. I mean, I did 151. Of course, there's probably not a lot of solvers, right? So it wasn't bad. An hour and a half, at least for me, is not bad, right? I could probably not. If I'm gonna be honest, if I was doing the competitive thing, I'd probably learn something like Python, and I'd probably learn to like learn a lot of more of the idioms and a lot more of the things. I do have a book that I've been reading, trying to do it in Rust to like get faster at these things. But especially at the end of the day, I don't. I just kind of want to do it to have fun. But I thought it went pretty well, so let's look at other solutions. We do have some comments. I think I made more off by 1 errors than nots. Yeah. Yeah, this is perfect. You basically are just saying, oh, this is even simpler than mine. No, this is mine, right? Yeah. It's just extra because I do this, and then I do the absolute value. What does his parse do? Oh, his already orders them like that. That's actually okay. That's an interesting thing. You could pre-order them all for your input. Notice in part 1, 2, and 3, we're doing like tuple windows, essentially. So we could actually do that in the parse input. Okay. Let's try this really quick. Oh, I don't put a 2 here. So then this, I just do change this to LR. That one. All strings. We'll have to iter here, but then we can call this start. And feels right. So we actually don't need this anymore. We just call this. Uh-oh. Part 3. They're all wrong. No. Oh. LOLOL. Okay, there we go. Back to good. Iter. Possible cut. String build back. Okay. That's a good one. Sometimes I don't do that with my input, but this is an interesting idea. Is like their notion is, oh, I'm gonna be making windows for everything, so I'm just gonna do that. One could argue you potentially didn't know you'd be doing that till the end. Although I don't think that's correct, because if you think about it, you'd always be like putting strings down. So this is definitely a good thing. Threads iter enumerate flat map overlap. So they have an overlap function, which is, yeah, okay. I think they're doing something similar to me. Because they're in order now, you can just do these type of thing. which is what I'm pretty sure mine does. I could add a overlap function. This right here, actually. So start, it should be S1 and in 1 L S2 R 2 1. And then I can do this one twice. Use where do I where oh these are all U size. Okay. So I can do the same thing down here then, presumably. Yeah, there you go. That does feel like it makes it cleaner. Okay. Well, this is an interesting optimization too, as they say, I'm really only interested in, threads I've seen before. Yeah. So this is just saying don't do threads I haven't seen before. So because this list contains all of them, I can just check the ones I've seen before. So that's a cool optimization. Okay, what else? Let's see. Who else did a solve? By adjusting the counts rather than calculating everything each time, starting with a slice from A to 1, it'd be by some careful count. Interesting. I actually don't understand how that would work. This creates all the links from 1 to 277, A to Oh, so you can I think the general idea is you should add a link if it's between A and B, but you remove a link if it's not between the other side. So like this has the effect of adding it if it's between these values, and this has the effect of removing it if it's not. And that's a cool idea. I hope that makes sense. Like the idea is you're not testing an overlap, you're just testing, am I inside this chunk? And then as you're going around, you say, oh, am I inside the chunk? And then as you're going the other way, you get rid of the ones that aren't inside that part of it. So that's interesting. Very cool. Let's see. Had to optimize early. So this looks like a very Python solution for the first problem, right? You basically just go through them. Is their absolute value half, which is my Rust equivalent was count intersections, AB zip nums, num1. Okay, so this is creating the strings. This does the swap. We sort them with their length. Add. This part starts to get to me. This part is pretty clear because you're just adding the values, or you're creating the strings, I guess. This add, what is it doing? Int I delta int none. Well, it's equal to I plus equal to I. Is this like it's doing the wrapping thing? Where is this add used? If someone understands how this one was solved, that would be interesting. a little more verbose than it should be, but mainly because I'm trying to utilize iterators as much as I can. Part 1, split by commas, parse, spec usize, windows, filter. Oh, there's an ABS diff. That's cool. But yeah, this is perfect. Oh, I guess they always return a string. Okay. Part 2, input vector. Sequence split. For the rfold 0. There's something about rfold that makes this better than just a fold. I actually don't know. Oh, there is some stuff. I know a lot of people that come from Haskell, like you can rfold it's faster or something like that. That's probably what it is. But it looks like it's basically the same thing, right? It's like min max the numbers, find the number of intersecting based on, you know, min max contains that one and it doesn't contain this one. Contains first or interesting. This is an interesting way to figure out if it intersects. Min max doesn't contain W0, W1. Oh, they're saying they're not the same. They're not the same one and contains first. Contains second. Sorry. Like a number overlap? I don't know. I'll have to read this one more too. Neatest, I'm sure. Kotlin. 305 milliseconds. Okay. I think I'm done. I feel like that's enough. Well, I'll have to read some more solutions, and if I find anything particularly interesting, I'll maybe do it in the introduction of the next video because this one's been kind of long. But okay, this was fun. Thanks everybody. We'll talk to you next time. Bye.